We see two big trends at the moment. A trend towards sovereign clouds and cloud repatriation.
We believe that using something open is way more beneficial than something closed. APIs should be open. They should not be regulated by a single vendor. They should be open so you have interoperability.
Christoph, nimmst du?
Yeah. Welcome to our presentation on deploying your own open cloud with Kubernetes. So to start things out, this will not be your typical marketing speech. We are not only here to sell you something, we're here to tell you a story, share some knowledge, and talk about how a bunch of open technologies together can help almost anyone out there build and operate their own cloud infrastructure as a very good alternative to the big hyperscale clouds. And looking at the news of the last couple of weeks or months, I think the topic of digital sovereignty, data privacy, having a hand on your own data became even much more important than 1 or 2 years ago. So we believe that this presentation could be quite beneficial for many of you out there. To give you a quick introduction, I'm here today from ScaleUp. I'm Christoph, the CEO and founder of ScaleUp. We are a data center and a managed service provider based in Germany. We operate data centers and cloud infrastructures, leveraging open source technologies and also open hardware. But at the same time, I'm also here to represent Stordis, our partner who's working on the networking part of the infrastructure. They will not be on stage, but we will talk quite a bit about their part in this whole setup. And we share a booth together on the show floor, so you're all very welcome to stop by there later on and say hi to us. And with that, I'll hand over to Christian.
Yes, so my name is Christian Berendt. I am the CEO and founder of the OSISM company and product. And so we are specialized on bringing a cloud platform based on OpenStack and Gardener on the market with a focus on the critical infrastructure so that it can be used in MilTech, GovTech areas, industrial manufacturing, and so on. And handing over to Markus from x-cellent.
Yeah, I'm Markus Fensterer. I'm the managing director of x-cellent Technologies. We are a consultancy based in Munich. And we also develop a software stack to control bare metal resources. It's called MetalStack. And we founded that. And yeah, we help our customers building open cloud systems in their own data center. Yeah, and what is the crucial thing that gets us together here, us three? That's the question. We see two big trends at the moment. So we have a trend towards sovereign clouds and cloud repatriation. And what is this? So sovereign clouds means you want to build really open system and you store your data there and you have the control over that. And repatriation means you're already at the hyperscalers, but with newer compliance regulations or now the situation with Trump and VMware, you decide you want to go back from the hyperscaler to your own infrastructure. And these trends are fostered or boosted by the fact that customers want cost control. So hyperscaler bills go up and up and up. And there is at some point a point reached where it is beneficial to operate things locally and you have less operating costs. And the second thing is, data security. You want your data locally, and performance-wise, it's also good to get local and stay local. If you deploy databases at hyperscalers, you may run into performance issues, and this can also be solved with local approaches. Yeah, and in the end, it's also about flexibility. It's good to know that you have the knowledge to operate things, that we keep that knowledge, and staying flexible in moving workloads. So these are the things we see, and multiple companies look at exit strategies from hyperscalers. Yeah, and now we look at bird view. How does an open approach look like? And Christian will tell something about that.
Yeah, so first it's important to mention that we focus on the build of clouds. So it's not about building a small virtualization layer or some next hypervisor, for example, based on Proxmox or libvirt KVM. It's about really building cloud platforms that are highly integrated in, for example, security processes, in onboarding processes for new customers, and so on. And because of this, there is a little bit of complexity. So it's not only you have some racks and you add some compute nodes there and everything is then working. It's more about how to do the zoning for the firewalls and how to deploy Kubernetes on top and how to make this visible in, for example, a netbox as an asset management. And so when you have a look from the top, in the end, it's just a bunch of hardware that's running in some data center, maybe your own data center, maybe in a co-location data center, maybe in some like Hetzner, bare metal, or LeaseWeb data center, whatever. But in the end, you have to care about how to integrate everything so that you have a cloud in the end, that you can run cloud-native workload on top, but also that you can data platforms on top as a requirement for AI, or that you can also provision bare metal nodes, GPU workloads, or whatever. So this is important to understand the next visualization, because this looks a little bit more complex. And this is the way we decided to build our cloud platform. So always, we think always in layers. And above, we have layers that can be stretched about different components of the stack, and can even stretch above multiple data centers or multiple regions, however you define it. So from our point of view, this is a so-called cloud pod. And cloud pod is a bunch of physical bare metal nodes, and bare metal nodes means open compute switches or open compute servers. So in the end, a switch is only a compute node with a lot of network interface cards. And then you can bring on this Sonic as a network operating system, or a Linux, maybe a Debian, or so an open Linux, not an enterprise Linux. And this is the baseline in the end. We have open compute switches as well as open compute servers. And on top of this, we can then care of the infrastructure as a service layer. We can use OpenStack for this with the Ironic, and we can do the bare metal as a service with the help of the OpenStack, or we can use the metal stack with the benefit that you then have Kubernetes running directly on the bare metal nodes. And then you have a solid bare metal as a service layer that you can use for virtualization, for containers, for GPU workload, whatever you want. You can just integrate this layer in your overlay layers. Like a Gardener by SAP for the automation of Kubernetes, when you are targeting Kubernetes clusters in the end. If you want to have virtualization, you can deploy compute nodes provided by OpenStack, or you can use KubeVirt running inside the metal stack. So there it depends, but in the end, it's important that you have always a Kubernetes as a service with all of the cloud-native features for self-healing, decentralized management of your payload. You have a single control plane. You have there the ability to add extensions. You can use ECLs. You can add it in your IPAR management and so on. And this way, you have in the end a huge fleet of bare metal nodes that abstracted in a single, not single Kubernetes cluster, but you have a single control plane, and then you can build the cloud platform on top. And this works pretty good. It can scale. You can exchange the vendors on the bottom, and then you always have everything running with this cloud middleware layer between.
Yeah, and let me emphasize one thing. So the whole stack, everything is built on open technology. So the idea is to really get rid of all of those legacy enterprise dependencies. And that's why I said in the beginning, this is not a typical marketing speech, because in essence, what we are presenting here is something that anyone could build, because those are all open technologies which anyone can leverage. So I think that's quite important, especially in regards to all the current trends and things in this world.
And it's important to mention it's open source and not open core. So everything is 100% open source software that you can use without paying for fancy enterprise features that everybody needs to run it in production. So this is a real open source based cloud stack.
So handing over to Markus.
That's a really nice stack. So all three of us use such a stack, and we are very involved here and very confident that it fits for others as well. And yeah, it's just amazing. It's open. It's not having a firewall appliance. It's not having VMware, and it works in production. We see later some references for that. Yeah, and to the key characteristics of such an open cloud approach, we can say, yeah, we have security by design, because yeah, there are existing blueprints and architecture principles for a network that ensure that we stay secure. So we have a concept for how our firewall is built. We have a leaf-spine topology, how the switches are connected, and also how to integrate intrusion detection systems. And this is all already there. Then we also do hardening of operating system images, and only hardened images are delivered to customers. So yeah, you just do a node roll on, and you get the newest hardened OS image. Yeah, regarding supply chain security, we provide also software bill of material of our software components that we write, and do vulnerability scanning. Yeah, and all of this is also compliance ready. So we did integration to corporate structures like ISMS systems and all this paperwork. This needs to be done for every enterprise at its own. And yeah, with such a solution, you can do that. And it's possible. We do automated security checks, and yeah, everything is deployed with a CI/CD pipeline, which also the compliance department loves. So normally you don't have manual administration on the worker nodes or the switches. It's all coming from a Git repository, and it's deployed with CI/CD. So this gives you a good standing point to address certifications like ISO, C5, DORA, and NIS2.
Yeah, talking a bit about the open hardware part in this whole picture. So the idea is to use open hardware technology, OCP servers. Those are the servers that we use in our use case, which help us avoid vendor lock-in because the technology is open and we can choose from multiple vendors. And at the same time, a very important aspect, at least for us at ScaleUp, is the fact that this hardware that we run is more power efficient than traditional servers. So we, by using this open hardware, this OCP hardware technology, save 15 to 20% on energy cost. Same server compared OCP versus traditional. And I strongly believe from a sustainability aspect in this whole approach, this makes a lot of sense, and it's also fully scalable. You mentioned the fact about open source and open software. So we believe that using something open is way more beneficial than something closed. APIs should be open. They should not be regulated by a single vendor. They should be open, so you have interoperability built into the stack. So quickly talking about some use cases, right, Markus?
Yeah, so we are running such an open cloud stack at FITS, which is a data center service provider for banks and insurances. And yeah, they are very strictly regulated by EZB and also the German BaFin. And 5 years ago, we started to build a system from ground up, from the data center ground, and engineered it new. And yeah, they have been in production since 3.5 years now. And the system runs in multiple regionally distributed data centers on over 1,000 bare metal servers. And yeah, as you can imagine, it's having quite important workload on it. And that shows it's really open source, and it's working for production.
Yeah, second use case that we brought is basically our own use case. So we tend to eat our own dog food, so to say, right? So we operate our own infrastructure as a service cloud platform built on this technology stack. So we had several iterations coming to the stack that we have today. So we have been operating OpenStack since 2015 already. Nowadays, our infrastructure uses open hardware, OCP hardware, open networking, Sonic, and the software stack built by Christian's company, and also partially funded by the German government with the SCS initiative. And as I mentioned earlier, we save on average 15 to 20% on energy by using this stack. So to wrap things up, we wanted to quickly mention how you can get involved in all of this, how you can learn more about using this technology. So easiest path is starting a trial using the infrastructure as a service offering. So Markus is offering something, we are offering something that's easy to do, and you can just get used to the stack and just use it from a more consumer-like perspective. That's probably the easiest part. Then we operate a so-called OCP Experience Center in Berlin. It's basically a space within our data center in Berlin where we showcase this open hardware technology and where we actually offer anyone to come, schedule a meeting with us, look at this hardware. You can actually run some POCs in the data center on this hardware if you want to. We have multiple hardware partners involved in this project, so this is an open space for anyone to try out these technologies. At the same time, we also offer, and you see those really nice pictures here, we offer like mobile compute racks where we can actually roll this infrastructure into your own office or headquarter, and you can just plug it into the next plug and try it out. And we also encourage everyone to join the Open Compute Project community. It's an open source foundation, open to anyone when you're interested in open hardware, open software, open networking. So with that, I leave you with an invitation to come to our booth, H09. You can scan the QR code to get some more information. We have another raffle this afternoon for a nice Atari console as well. We still have some socks left, I believe. We have fridge magnets and many, many other things. So lots of reasons to stop by and say hi to us and talk to us in person. So thank you very much.
Thank you.
Thanks.